I think I am live now. Can anyone confirm if audio and everything is fine before we get started? And like, how was your contest? Like, how many problems were you able to solve? Like, really, that can give me a brief idea of like which problem would be like the most people would like to hear solutions on. Okay, Akash says two problem. Okay, I am planning to discuss the first five problems. Like, can anyone confirm if audio, like, if multiple people can confirm if audio, at least D, please. It would be C only got to stuck on C forever. How to solve CD till B nahi hua. Can you take time complexity in into okay? Like looks like most people were stuck on C and D. And thanks Raj for the audio. No, like even if this was your first contest, it's definitely rated for you. Like just that rating will take around 24 hours to get updated. Okay, Crazy Tourist is also stuck on C. Okay, ABC, yeah. So yeah, we can we can start now. So like, just give me a minute. Huh? Okay. Yeah, like I will answer questions from the chat. Like once I'm done with discussing all the problems, so that ones who want to discuss solutions, which were just here for discussing solutions, can probably start something else. Looks fine. Okay, yeah, let's get started now. The first problem says Monocap is working on his new site, and the current challenge is to make the users pick strong password. Monocap decided that strong passwords should satisfy the following condition. Password should consist of only lowercase Latin letters and digits. There should be no digit that comes after a letter. So after each letter, there is either another letter or the string. And all the digits should be stored in sorted non-decreasing order. All the letters should be stored in sorted non-decreasing order. Note that it is allowed for the password to have only letters or digits. Monocap managed to implement the first condition. Like this one is given to us, but he struggles with the remaining one. Can you help him verify the password? Now there are multiple passwords given here, and we have to say yes if it's a strong password and no if it's not a strong password. So like the idea is like it says we have been given a string S which consists of lowercase letters which is A to Z and digits which is 0 to 9. Although it asks us like all the digits should be in increasing order, like basically 0, 0, 0, 1, 2, 3, 3, 9, etc. is allowed. But let's say if 9 is in between, like if there is a character which appears before something else, then this string is not allowed, 0091 as well. And similar is the case for letters like A, B, B, C, D, Z, etc. Like characters in this form are allowed, but out of order like A, Z, B, like characters like this are not allowed. And also it says like after every character, like only characters should appear. So basically before the first character, like all the digits should appear. Like after a character, like digits are not allowed. There are many ways to do this problem. One of them is like you can check all these conditions one by one and verify if that condition holds or not. And like if you look at the samples 1, 2, 3, AC is fine because after all the characters, only characters are there and all the letters, digits and characters are in increasing order. Similarly, almost is wrong and A, L, M, like M, N, O, P, Q, R, S, T, U, N. No, almost is fine. 1, 2, 3, W is not allowed because W appears before A. And similarly, A, C, 1, 2, 3 is not allowed because 1 appears like after C. And 0, 0, 1, 6, 7, 9 is also allowed. Or like there is one shortcut approach you can also use. Like you know that like all the characters should be in increasing order and all the digits should also be in increasing order. And also we know that like if we look at ASCII values, 9 is less than 8. Like so like this is the chart we have. There is no need to memorize the values of the ASCII chart. It's just enough to know like where the characters appear. So for example, 9 appears at 39. Like basically when you convert character 9 to an integer, you will get 39. And like A appears at 61. So like it also holds that 9 is less than A if you look at it in character form. So like the condition essentially reduces to all the characters should be in increasing order. Because we know that the digit 9 is less than digit A. So basically the condition reduces to like all the characters should be in increasing order. Like it's not because like also you can see that all the characters here are in increasing order only and all the digits are in increasing order and all the characters are also in increasing order. So like it's sufficient to just check like if the given string is a sorted string or not. So we can check if the sorted string is there, we print yes, otherwise we print no. So like that can make a problem bit faster over here. And like that was essentially my submission for this problem as well. Like I took string S, I copied it to another string, I sorted the string T and checked if T is less than equal to S, print yes, otherwise print no. And like as Dimitri mentioned, there is also a built-in function is sorted. Like you can also use that method as well. So you can also use this method as well and print yes if it exists and no otherwise. So like any questions on the first problem before we move to the second problem? So if there are any questions on the first problem, like I can answer that, otherwise I will move to the next problem. Okay, let's move to problem B. Problem B says we are given two integer arrays A of length n and B of length n plus 1. You can perform the following operation any number of times. Choose any element of A increase by 1. Choose any element of A decrease by 1. Choose any element of A, copy it and append the copy to the end of the array. So what it says, like let's take some samples as well. So for example, the first sample is like we have been only given one digit number, only one character 2. And finally we want an array which contains 1 and 3. And like what we can do is we can choose any element, do +1 to it at any point, choose any element, do -1 to it, or copy it and add back. And it asks us like how many times we have to do operation to get the second array. The critical part over here is like the length of A is already n and length of B is n plus 1. So like we will do this operation copy only once, because once we do this, like the new array has n plus 1 length. And also like notice that the new element is always added at the back of it. So like for the elements like A1, A2, A3, A4 up to AN and B1, B2, B3 up to BA and BN plus 1. Like A1 must be transferred to B1 like using +1 -1 operation only. Like, because like the new element is always inserted at the end. And for creating the last element, what we will do is we should copy from somewhere and then do +1 or -1 if required. So for these elements, what we can do is like, if AI is less than BI, like we will do plus operation, like plus operation BI minus AI times. And if AI is greater than BI, we will do minus operation BI minus AI minus BI times. Like, so basically, like for the first n numbers, we know like how many times plus and minus needs to be done. And we know that the final number bn plus 1. So notice, like for example, if you change 5 to 10, then at some point of time all the numbers are there, 6, 7, 8, 9, and then 10 appears. Or if you make 15 to, like let's say 12, then there are all the numbers 15, 14, 13, like, because when you are doing -1 operations. So what first thing you can check is like if bn is between any of the numbers, like either ai less than bn plus 1 or less than bn, or like does this holds for any numbers. If one of this condition holds for any number, then we know that like definitely, like whenever we are changing ai to bi, there would be some point when bn plus 1 would be there, and then we can just make a copy of it, and we only need one extra operation. Otherwise, like we can compare with ai and bi individual values and see which one is nearest to bn plus 1. So like, to some, like let me give some examples here. Like for example, if we look at the first sample, initially we have 2. What we should do is we should make a copy of first of 2 first, and then we should change this 2 to 1 and this 2 to 3, and overall 3 operations would be required. Similarly, we have another case, 4 2 1 2 2 1 5 2 3. So like this 4 will be changed to 3 and 3 will be changed to 2. Similarly, this 2 minus 1 times becomes 1. This 1 will be changed to 2, 2 will be changed to 3, 3 will be changed to 4, and 4 will be changed to 5. 2 to 2 remains same. And notice that we need final number 3. And when we are doing this, there would be some point when we will have 3. So like at that point, we can make a copy here. So like to summarize, when we are changing this 4 to 3, after it becomes 3, first thing we do is we make a copy here. And then we perform the remaining operations. So overall the operations required here would be like, this change would require 2 subtraction operation, this change would require 1 subtraction operation, this change would require 4 plus operation, this change does not require any operation, and creating it only requires 1 operation. So overall the answer here is 8. Similarly, like let's just modify this sample only. Let's say this number was -5. So the idea would be like at starting itself, we will make 1 to copy 1, like take the minimum element here, and then we will change it -6 times. Or like, let me take some more examples here. Let's say this is what we need, like this is given to us, and this is the final array we need. So we know that we have to do plus 2 times, we have to do plus 1 time, we have to do -1 one time, and to get 1 here, what we will do is when we get 5, we will make a copy of 5 here and then 4 minus operations here. Or let's say like we had a different case where like this number was 7. So in that case, what would have we done is like in the first case itself, we would have made a copy of 6 here and then we would have made it 7. Or similarly, let's say it was 9. So the nearest element to 9 over here is this 10. So we in the first operation itself, we would have created a copy here and then we would have done a subtraction here. And like essentially like this was the idea. Like the idea was like find the nearest element of B and then like make a copy from there itself and then do plus minus subtract operations you need there. So yeah, that was the idea. Like I will share the code as well. Like in the third case, the idea is when we are changing this 4 to 2, like 4 minus 1 becomes 3. Make a copy there and then change the part here to 2 again. So like I will write a better code. Like these would be the number of operations we need to change the first n elements. Like this is the last element, right? If AI is less than BN, then we will try out something. Else we will try out something. If Bn is less than equal to AI, then change last would require if Bn is less than equal to Bi, then like whenever we are doing plus operations here, so we should make a copy at that instant and we can say change last is 1 there. Otherwise we will make a copy. Otherwise make a copy at the end. So like if an is less than, then these are the cases. Otherwise like the sequence remains same, but like the cases change. If bn is less than an, make copy at the end, like once you are done with all the changes. But here would be then we are doing subtraction option. At some point ai will be equal to bn, so number of make a copy at that instant. Otherwise we should make copy in starting. And like essentially like these are the cases there. And like the number of operations required for all the elements. plus the number of changes required for the rest of the elements. And this is the solution for it. Yes, instead of comparison, we can take absolute value, like, because like -5 will also give us 5 subtraction operation, plus 5 will give us 5 operations only. Like what matters is like how much is the difference. Whether it's negative difference or positive difference doesn't matter. The number of operations would be same. And so like essentially like this is the solution. A bit tricky one. Like I also got a wrong answer on test 2 because I ended up missing some of the test cases there. And any questions on problem B or like some examples or something which was not clear, then I would be happy. Like this problem is more about looking at different examples, and I can share some more examples which can help you visualize what's going on there. So like okay, I am assuming D Harris is someone whom I have met in real life. I took the last element of B, then checked mean absolute difference in comparison to A and added to rest. Then added the absolute for all the elements in A, but it failed in, yeah. Like that, I think that is the case where like sometimes like there are three cases. Either you copy in between, you copy in starting, you copy in end. And the very first time like I missed copying at the end case. Okay, let's go to problem C then. Like x of is equal to ai minus bn and bn minus bn is not enough. Like if there are cases when like ai is between bn is between ai and bn, then you just need one copy operation. You don't need like the plus minus operation for the last element, because whenever you are doing plus and minus operations there would be an instant when bn would be there. So let's start with the C problem. It says Monocap is opening his IT company. He wants to hire N programmers and M testers. There are n plus m plus 1 candidates numbered from 1 to n plus m plus 1 in chronological order of their arriving time. The ith candidate has programming skill AI and testing skills BR. And a person's programming skill is different from their testing skill. It's given AI is not equal to BR. The skill of them is sum of programming skill of all the candidate hired as programmer and sum of testing skill of all the candidates hired as tester. Your task is for each candidate calculate the skill of team if everyone except them comes to the interview. Note that it means that exactly n plus m candidates will arrive, so all n plus m positions in the company will be filled. So like this problem is also looking about the samples here. In the first test case, we have two candidates. Programming skill, let's call it programming skill, testing skill. The first candidate's programming skill is 2, testing skill is 1. Second candidate's testing skill is 1, programming skill is 2. And we should hire one programmer. So like if the first candidate does not comes for the interview, then like this person would be hired and the programming skill is 1. Like that's why the answer is 1 here. And if the second person does not come for the interview, then the first person would be hired and the programming skill would be 2. That's why the answer is 2 here. Like let's take the third example now. Two one five four 5231. and we need one programmer and two testers. So the idea is like, if the first person does not comes for the interview, then when this person comes, he would be hired as a tester because his testing skill is more than the other skill. When this person comes, like he would be hired as a programmer because his programming skill is more than testing skill. When this person comes, like his programming skill is more than one, but we have already hired one programmer, so he would be hired as a tester. So in that case, the answer is 5 plus 2 plus 1, 8 here. Now let's say the second person does not comes for the interview. First person would be hired as tester, his testing skill is more. Second person would be hired as a programmer, his programming skill is more. And the same situation for the third test case. Like his programming skill is more, but like we only need one programmer, so he would be hired as tester. That's why the answer is 11 in this test case. Similarly, if the third person does not come for the interview, first person would be hired as tester, second person will also be hired as tester, and the third person would be hired as programmer. And in this test case, like the answer is 11. And if the fourth person does not comes for interview, first person would be hired as tester, second person would be hired as tester, third person would be hired as programmer. And the answer in that case is 12. Yeah, like that does makes problem a bit more difficult if like we are not allowed to interview in the order which is given to us. So like this was the crux of the problem. Any questions on the problem statement first before we move and try to solve this problem? Like I will also discuss problem D, like after C, the next problem would be D. Okay, so let's look at this idea. So like let's do it this way. First, let's assign people in the order like whatever the best skill they have in that order. So like first, let's say like we have P1, T1. And let's forget like how many programmers we need, how many testers we need. So like if this is the order, then instead this one is the programmer choice, tester choice, programmer choice, and tester choice here. Like if we don't have any condition, like if we don't have any condition, how many programmer we need, how many tester we need, then this is what we will do. And let's say we need only one programmer. Then you can see like if this person does not comes, then this would be selected as programmer. If this person does not comes, then this person would be selected as programmer. In any case, like third, if we only need one programmer, third programmer onwards will never be a programmer. Like does this looks fine? Or like let's say like even do it P1 greater than T1. Like let's just add more examples here. If we need only one programmer, then or like probably let's make it we need two programmers. If we need only two programmers, then if someone is Like 1 second. Like if either n or m reach limit, we don't need further. That's correct. But the idea is like if we need n programmers, and let's say there are more than n plus 1 programmers, then first, second, third, fourth, n plus 1, n plus 2, and up to whatever the count we have. If a tester is absent, then all 1 to n would be selected as programmer, and these would be the tester guys. If programmer greater than n plus 1 is absent, then only 1 to n would be selected, and rest of the remaining people would be tested. Critical part is if someone among 1 to n plus 1 programmer is absent, then like remaining people in 1 to n plus 1 will be selected as programmer, and the rest person would be the tester. In that case, like whoever is absent will definitely not be selected, but everything, all the remaining people would be selected here. Like any questions on these statements so far? Like there are three test cases: either tester is absent, or among programmers someone after n plus 1 is absent, or someone before n plus 1 is absent. If tester is absent, then first n programmers would be selected. Assume that we have more than n programmers with us, and like if someone among first n programmers is selected, then n plus 1 programmer will also be selected, and all the rest would be testers always. And similarly the case like if someone among the testers, so what I can say is I can mark these as testers directly. Because these people will never be programmers. So like you see, like we will keep a check on it. As soon as n plus 2 programmer comes in, we will mark is a tester, and like we will continue marking all the people as testers there. And similar can be the case for programmer as well. So what we will have is at the end of the day either n plus 1 programmers and m testers. This can be the first case when we have more than n plus 1 programmers initially. Or the other case would be n programmers and m plus 1 testers. Because as soon as like we get more than n plus 1 programmers, we will just mark them as testers, irrespective of what their rating is. Like this was like I was looking at, like there can be testers in between, but that was fine here. So like that is the first thing I will do. So like let's look at it like this. I'm maintaining a list of programmers and testers. Along with that, I'm also maintaining the index where a person is. If I have sufficient number of program testers, I will not even check who the programmer or tester is. I will not even check skill here. Similarly, if I have required number of programmers, then I will mark all the coming people as testers here. Otherwise, if testing skill is more, I mark the person as tester, or if programming skill is more, I mark the person as programmer. Looks good so far, right? And like the idea is Now in that case, if someone among from here is absent, then total skill minus this skill is required. And if someone here is absent, then this programmer also becomes a tester here. Like we need only one movement now. So like give me some examples here, like that will make it like the sample examples are not at all good. So like just give me an array of programmer, tester, number of programmer, number of tester, like I will try run it. So like just give me an array of programmers and testers for a try run. 5, 4, 3, 6, 3, 5 and 1, 2, 5, 4, 8, 9. 1, 2, 3, 4. 6 people are there. And let's say we need one programmer. Like total number are 6, so there must be 3 programmers, 2 testers. But that will not make life easier. Let me take one programmer and 4 testers. So like this person is definitely marked as programmer. This person is also a programmer. This person is a tester. And like I only need one programmer. And I already have 2 programmers. So even if this person has a better rating, I will mark it as a tester here. Similarly, like this person is a tester only. Let's make it 9.5. This person is a programmer, but I only need one programmer and I have already got 2 programmers. So like I will mark this person as a tester as well. So at the end of the operation, I have 2 programmers, 4 testers. Like, does this make any sense? The idea is like, if I need 4 programmers, then from 6 programmer onwards, like that will never be taken as a programmer, that will be taken as a tester only. Because 4 programmers are required, and like among the first 5 people, there can be a choice. Like if someone among them is absent, then the 5th person can be the 4th programmer. But 6th person will never be a 6th person can never be among first 4 programmers. So like that is what I did. So like I started, like I took the skill of tester programmer. If I need M testers and if I currently have M plus 1 testers, then mark the current person as a programmer directly. There is no need to check if which skill is better. Similarly, if I have N plus 1 programmers already, then like whoever comes will be directly marked as tester because that person can never become a programmer. Otherwise, based on the skill, I mark them as programmer tester. So after the end of the operation, either I have N plus 1 programmer and M testers, or M plus 1 programmers and time complexity would be N plus M plus 1. And the next critical piece is like I have let's say this P1, P2, 2 programmers, T1, T2, T3, T4 testers. So if let's say I take everyone here, then I can like now if like let's first calculate the skills of all of these here. And like the idea is like if P1 is absent, then we can only subtract the programming skill of P1 and like get this as an answer. Or if P2 is absent, then we can take P1 as the programmer and these guys as a tester. So we can only subtract the skill of P2. Or if some tester is absent, then this programmer becomes a tester here. So we can take like, we can remove the skill of this person, we can subtract its programming skill and add testing skill upon. of P2. And essentially like this would be the idea. But surely you have to go through all programmers every time to see which one is left, which and find the difference. Like no, like what I'm taking is I'm making a base case of programmers there, and then I'm just checking like every time someone is absent, only the last programmer would be the one who would be making a difference there. Like the only case is whether n plus 1 programmer is a programmer or a tester. That's the only difference. Now if I have extra programmer, then like I initially assigned like the skill as sum of all the programmers testers I currently have. Then whenever some programmer is absent, then for that index I just subtract that programmer's skill. Or if some tester is absent, then we need to subtract that tester's skill. And we also need like the last programmer, right? Subtract like the last programmer's programming skill and make him a tester here. So like this would be the solution. Similar is the solution when we have extra testers here. And like essentially like this is the solution I had. Any questions on problem C before we move to problem D? Category would be a bit different. Okay, I will move to problem D then. This one is a bit tricky. It says invertible bracket sequence. Look, I did not do it using binary search. A regular bracket sequence is a bracket sequence that can be transformed into a correct arithmetic expression by inserting character 1 and plus between the original characters of the sequence. For example, sequence this can be transformed as 1 plus 1, and similarly sequence this are not the regular bracket sequence. It's a bit of standard definition. What it says is like for every closing bracket there should be one opening bracket just before it, and for every opening bracket there should be a closing bracket just after it. You are given a regular bracket sequence as like this is critical, because like if that is not the case, then the problem becomes a bit non-trivial. Calculate the number of pairs L and R such that if we replace the substring from character L to R with its inverse, S will still remain a regular bracket sequence. So for example, in the first test case, like the only pair is like when we swap the second and third character. So the new string becomes this, and like this is still a regular bracket sequence. Similarly, in the third test case, like there are many ways. Like either we can subtract these two characters to get this one. We can subtract these two characters to get this one. Like one thing to note here is like it's not reversing the string. It's replacing opening character by with closing bracket and closing bracket with opening bracket. Like this difference becomes a bit critical when we try to solve this problem. Although like assuming the other case will also not make much can guide you to towards a different problem. And in the third problem, like if we change like this string, then this is required. And like that can be a problematic here. Like I will give you an example. No one, two. Let's say this is the original string. And we probably want to change. Like let's say if you swap this string, then if you reverse the string, like your string becomes this. But if you invert the bracket, like this is the incorrect assumption. What we are doing is we are reverting the bracket. So like after reverting, the string becomes this. Although like assuming otherwise might not make a difference here, but like this is critical, and like I have seen people getting confused between these two types of operations. Like what we are doing is we are replacing, choosing a sequence L2R. We are changing closing bracket with opening bracket with closing bracket. What we are not doing is like we are reversing the substring and putting it back. So like that was a bit critical piece. Now something like we will pull up one like because we are given it's a regular bracket sequence. Let's pull up like yesterday's +1 -1 trick again. Replace all opening bracket with +1, all closing bracket with -1. So like we will have bunch of characters here. What would be there is sum of all the numbers is 0. And like we can again replace it with by prefix sums. The critical piece here is like when you are changing some substrings from L to R, number of opening bracket in this sequence should be equal to number of closing bracket. Otherwise, like what if you do the operations like either number of closing bracket will be more or opening bracket would be more. So like this one is a critical piece. Like any questions on this one? Like why whenever you change a sequence, like the number of opening bracket in it should be equal to number of closing bracket? Like once we know this, what we really need is like we first create a prefix sum array. By replacing opening with +1 and closing with -1. Then like number of characters equal from L to R is essentially saying that the sum of that sequence should be equal. So like it will again turn out to be like we can only make swap between L to R if PR is equal to PL -1. So if you look at original string and if you look at all the indexes in the original string, let's say like this is how the prefix sum looks like. Then like you can only choose indexes with the same value. So what we can do is PL minus 1 is PR. Okay, can I draw the original string here? Like I can take like here like prefix some 0. Okay, let me erase few steps here. Zero, 1, 2, 3, 2, 3, 2, 1, 0. Here it's 3, 2, 1, 0. Like the idea is like this sequence has same, like this bracket has same number of opening and closing bracket. So you can sort it like in prefix sum like 3 and 3 are equal. Or like if this has equal number of opening and closing bracket, then like this 2 is equal to this 2. Like no, numbers are like extra opening brackets we have so far. That is one way to call it. The other way to say is like, yeah, that is a better way to call it. When we look at the string from starting to the ith character, how many extra opening brackets do we have? That is what we can say like these numbers are. So like when we get an opening bracket, we increase the extra opening bracket count by 1. When we get a closing bracket, we say, hey, we have found one closing bracket, so decrease the count by 1. That is one way to do it. The other way, what I was saying was replace opening bracket with +1, closing bracket with -1, and take the prefix sum of this array. Like the trick I have pulled is exactly same as yesterday's code stuff problem. And like that's why up solving is a bit important. Here also like the sum of mod, the string, the problem reduces to like we have only 2 types of characters. Count the number of substrings which have equal number of both the characters. So like let's move forward. Like the reason why I took plus minus 1 analogy was like let's say we have this string p1, p2, pl minus 1. PL, PR. And let's say we want to subtract this string. So all +1 will become -1 and all -1 will become +1. And what we really need is like even after doing this replacement, like the prefix sum, the maximum possible value of prefix sum is still positive here. So like if we look at it like this, we have this string which we have replaced. We have PL minus 1, extra opening brackets. So what we need is like at any point of time, the number of extra closing bracket in this sequence is less than equal to PL minus 1. That's why like overall the sequence will remain same. And like this is only the condition we need to ensure that the final string remains the same. Any questions on this one? Like if we have PL minus 1 extra brackets before the string we reverts, then if we only look at the segment which we have inverted, there should be no point in time when the number of extra closing brackets is greater than equal to is more than PL minus 1. Or other way to say is like should always be greater than minus PL minus 1. Like now, if we allow like the number of opening brackets to be extra opening bracket to be negative, then in this segment the number of extra opening brackets should always be greater than equal to PL minus 1. And once we look at this, the idea is if we create a new array for this one, where the first value is so like let's pick any index I here. If we do not reverse, then extra opening bracket in this segment is Pi minus PL minus 1, right? If we only look at this string from L to R. Like there is some string before it, there is some string after it. Up till here, like there are PL minus 1 extra bracket. So if we pick an index I, the number of extra brackets when we are here is Pi. So like the number of extra opening bracket in this range would be Pi minus PL minus 1. Although this number can be negative here. Like any questions on this one so far? Before I try to manipulate things here. Okay, I will move further. After reverse, extra closing bracket would be Pi minus PL minus 1. Because all opening brackets will become closing bracket, all closing bracket would become opening bracket. And like the only necessary condition we have is this should be less than equal to PL minus 1. So if we transform numbers here, what we will get is Pi is less than equal to 2 times PL minus 1. So if we want take a string L to R, then like this is PL minus 1, then all the numbers here should be less than equal to 2 times PL minus 1. Like this is the only sufficient condition, and also the case that PR should also be equal to PL minus 1. Like these are the only two conditions we need to check if the string is regular balanced or not. Any questions on this one before I move to counting part? Like now if we have something which allows us to find the maximum value in a range, then we can check in order one like whether the final string would be bracket sequence or not. Okay, once we know this, like any questions so far? Like because taking a pause is important. Like why these two conditions would be enough? Yeah. So what I was saying was, let's look at this string. There are PL minus 1 extra opening bracket before we change anything there. And if we pick any index I, the number of extra bracket between L to I index would be Pi minus PL minus 1. Looks fine, right? Like although this number can now be negative. Like the extra opening bracket can be minus 5 as well. And once we do the reversing operation, like the number of opening bracket will become closing bracket. So like the number of extra closing bracket would be Pi minus PL minus 1. And what we need is like overall if we look at the string as a whole, like the number of extra opening bracket should never be negative. That's why like the extra closing bracket in this segment so far should be less than PL minus 1. And now the problem was manipulating this to get PI minus 2, PL minus 1. So like the number of extra closing bracket in our reversed segment would always be less than equal to the number of extra opening bracket just before this segment will hold true only if PI is less than equal to 2 times PL minus 1. And if this should hold for all the index I, then we can also say that the max value of Pi where L is between I is less than equal to R should be less than 2 times PL minus 1. So like this was the condition which I was referring to. So any question, like the first condition is a bit tricky one. Any questions on this one? And like the second condition was the obvious one, like to ensure that the number of opening bracket and closing bracket after reversing the string should also be same. That's why we have PR equal to PL minus. And once we have these two strings, let's fix value of PL minus 1. We can iterate on all of them. So like we will get some strings. Like we will have some set of strings like this. Some more characters before it. Some more characters after it. Where like all the characters would be same here. Like let's pick PL minus. What did you explain by max thing? What I was saying was like Pi less than equal to PL minus 1 should hold for every index which is between L to R. And the easiest way to check is it like look at the maximum value in that range of Pi. And if that is less than 2 times PL minus 1, then all the indexes would be less than 2 times PL minus 1. And what we need to do is like we can individually check if like now if we look at this grouping, let's say like this string allows changing and the string will remain balanced after this. This string, if we only reverse this segment also, then let's say based on these two conditions, we say that we can reverse the strings here. But if we reverse this part, then let's say the string is not allowed to be reverted. And let's say like if we reverse this string, then also we are allowed to reverse this string. Like we can individually find for each segment like this. That we can do, right? If we maintain a segment tree to get maximum between a range, then we can always check for all of these segments here. Like I am just looking at the smallest possible segments here. Like I am not looking at the larger segment to begin with. Then like if reversing this, then the next thing to note was if reversing this string keeps the string balanced, and if reversing this string also keeps the string balanced, then if we invert this complete string as well, then also our string will be balanced. And like that was the last critical observation. So like the next thing would be like we can keep maintaining how many segments so far were balanced. Whenever we get any unbalanced segment, we reset our count to 0. Otherwise, we increase our count by +1 and we keep adding the things there. And like that was the final solution. Like I have a range max segment tree. First, I create a prefix sum array for opening bracket. And we can add a constraint that all the extra closing bracket initially would be positive. And at last also like this should hold. And the next idea is we group each of the sequences which have the same values. So we have an index array I. And now we look at the value like PL. Let's call it PL. Let's call it PR mostly. This way we can get all the indexes where PR exists. If the number of places where this index exists is less than 2, then we simply skip it. Otherwise, I have an answer variable and I have a counter variable. So I look at each segment. This would be my PL. And this would be my PR. Like if I look at the individual component. And then I take like this as this is range max segment tree. So if between index from L to R is less than PR or PL minus 1, then I say like the current segment is valid. So I increase my previous count plus 1. Otherwise, I say then like the number of segments, including this and if I take some from previous one would be 0. And answer plus equal to count and finally print answer at last. And like this was essentially the code for this problem. So any questions on this one before we move to the next problem? Okay, CF step says like he will probably create a practice problem with some similar problem. So you can wait for his Codeforces blog where like he would share some similar problems to be solved before. And like essentially like this is the code for this problem. Any questions on problem D before we move to next problem? Okay, in that case, I will move to problem E. Problem E says initially we have one array, which is a permutation of size, and like all the integers from 1 to n appear exactly once. We performed Q operation. During the ith operation, we did the following. Choose an array which has at least 2 elements. Split it into 2 non-empty arrays, some prefix and some suffix. Now let Li be the maximum element in the left part, Ri be the maximum element in the right part. Now remove the original array and add the remaining 2 parts in our remaining part. Example is given, like we have this as a permutation. We take the complete array first, split it into 2 parts, 6, 3 as 1 and 4, 1, 2, 5 as 1. So the maximum in the first part is 6, maximum second part is 5. So we note down L1, R1 as 6, 5. Now we have 2 arrays. Next time we choose this array, we split it as the first 3 characters and the last character. Maximum in the first part would be 4, maximum in the second part is 5. So we note down 4 and 5 and now we have 3 arrays, 6, 3, 4, 1, 2 and 5. Now we take 4, 1, 2, we split it as 4 and 1, 2. Maximum in the first part is 4 and the maximum in the second part is 2. So we write down 4, 2 and now we have 6, 3, 4, 1, 2, 5. And it says we are given the sequence of L1, R1 and we have to count the number of possible permutations using which we can perform some operations to get these values as LIRI. And one additional important constraint is given that there always exists a permutation which can give us this sequence. So the answer is at least one. So any questions on the problem statement first before we move on how to solve this problem? So like my idea is, like we can first ignore all the indexes which does not appear as input. We will decide how to place them later. And all the indexes which appear in the string, like there is only one fixed order. Like all the values that appear in input, like there is only one fixed relative order for them. All missing values should be added in between. Like let's take an example here. Like in the first example, like let's take this one only. 654542. So like 6 must always be on the left side of 5, because like that's when you split that array, like 6 will be on the left side and 5 would be on the right side. Similarly, 4 should also be always on the left side, and 2 should be all, like the other way to look at it is, like we have numbers, like what we can do is, like we can maintain a linked list kind of a thing, where like let's two, 4, 5, and 6. Like this order is always fixed, and like remaining element 1 and 3 would be inserted in between them. So like that is the idea. What I will do is, like let's say we somehow maintain a linked list where for 6 we have only 6 right now, for 5 we have only 5 right now, for 4 we have only 4 right now, for 2 we have only 2 right now. So like what I will do is, so like first time we have 6 and 5. So we know that 6 is before 5. What I will do is, like I will erase this string and I will merge these two sets. Like let's say after 6, 5 appears, and this is the order we have. Second time we have 4 and 5. Like 4 and 5 can never be the case, right? Okay, let's start from ending first. Not from starting, end first. Let's first look at 4 and 2. So like what will happen is like now we definitely know that 2 appears after 4. And like this is how our linked list, linked list looks like. After 4 there would be 2 and the maximum of this segment is 4 right now. Like in the problem statement we were splitting segments. What I am doing is I have splitted segment, I am merging it to get the order I want. In the second segment I have 4 and 5. So what I know is like 5 should appear before 4 and I can again merge these segments here. After 5 4 should appear and after 4 2 should appear. Like when this is the case. And now we have 6 and 5. So like overall my order would become 6 5 4 2. Like this is the fixed order and this cannot change. What remains is like we have to put 1 and 3 in between them. Any questions so far? Like implementation detail we will go through it. Like let's say for now we are maintaining this linked list kind of a thing. So for each segment we know the first element, we know the last element. And then we would be merging some segments which are near to each other. Like if this is the order, then only there is a way to get those operations. Like we can split first time here to get 6 5. Next time we can split here to get 5 4 and we can split here to get 4 2. So like that is the first piece. And once we know this piece, what we can do is like I think it was 6 5 2 4. 6 5 6 4 2 5. Probably like looks like I matched up somewhere. Like this array is 4 5, right? Sorry. So 4 2 should appear before 5 here. So like when we are merging 4 5, it should be like this. Four, two, 5, and overall the order becomes so like once we look at it, let's insert number in decreasing order. Like what all places can we insert 3? We can insert a 3 before this 6. We can insert a 3 here. We can also insert a 3 just after it. We can insert a 3 before 5. We can insert a 3 just after 5. Total choice, there we have 5 choices. And the idea is like when I look at all the elements which are greater than 3, this forms a consecutive segment of 2 numbers. This forms a consecutive segment of 1 number. So we have 2 choices here and 3 choices here, total 5 choices. Let's say we have inserted 3 somewhere. Like the idea is, look at, like let's say if I have numbers from 1 to 15 and I want to insert it, I can insert 8 after wherever 9 is, 10 is, 11 up to 15 is. So there are around 7 choices here. Like basically I have 7 different choices. Like when I am inserting it, I have already inserted all the numbers between 9 to 15 in my array somewhere. So I have 7 possible choices, 7 possible different numbers, after which I can insert the number 8. And like, but that will not hold true, like how many numbers I can insert before it. Like for example, if the number is 9, 11, 12, then inserting just after 9 is same as inserting just before 11. Inserting just after 9, 11 is same as inserting just after 12. But inserting 9 is different over here. Let's say if a 3 exists here. So like I can also count like how many just insert just after and insert just before are same. So like I can reduce that 2 into minus common points. Like those would be the number of possible choices I will have for inserting all the remaining elements. And essentially like that is the idea. Other way to look at it is like if we look at it as a connected component, then in each linked list there would be a head there. Or we can even look at when we are building the original string as well. Like we can look at like how many strings have head which is greater than 5, and we can insert those numbers finally there. And like that was the solution I have, and I will probably code it now. Like I ended up using DSU and all, but I don't really need it. I have taken all the numbers as input, zero based indexing. Like I have like instead of linked list, what I am maintaining is I will maintain an order of elements. Where I say the next element is 1, and for each element I maintain the first element and the last element. And now I am looking at the numbers from the reverse. I know L, I know R. So I look at the chain of L, I look at the chain of R. Next element of the last element of first chain would be the first element of the next chain. And I can erase all the numbers now. And I can put like the first element of the first number and the last element of last number would be my new chain. And that will correspond to maximum of both the numbers we have. At the end of the day, we will have only one element. First element would be sg dot, like this would be the first element. And now I can find the order. Like as long as we don't read the last. Like I also need like the index where all the elements appear. In the sequence we have. Like the extra head I have is 0, and like my answer is the final answer. I go from decreasing element. Let's say it's -2. If the element is already one of the existing element, then like I would create a link starting with it. And if the element just before it is greater than this, then like this head would essentially end up combining with the other element as well. Similarly, if the element just after it is also same, then this head will also combine here. The largest number of elements would be this. These are the places, these are the numbers where we can insert just after this. And like these are the places where we can insert just before them as well. And like just multiply it for all of them would be our final answer. So this was my solution. Any questions on this one? And with this, I'm mostly done with today's stream. So any questions you guys have related to this contest or anything else in general, like I would be happy to answer them. And the place where I made mistake was finding the initial order initially. And like I haven't really spent a lot of time on F, so I don't really know how to solve problem F as well. So like 7 wrong answers on test case 7 will be Thala for a reason. So any questions related to this contest or anything else in general? Can you explain me one question that is not related to today's contest? Like I will probably skip it. If I have seen that problem before or solved before, like I can probably answer that on Discord. Otherwise, I will mostly skip it. So you can send the problem on Discord. I will take a look at it. If that's something which I have solved before and in the recent time only, and I remember the solution, like I can probably try to explain that. Or probably if someone else is active on Discord, like they can also try to answer. Maybe. So any other questions or anything before we call it a day today? Guys, like thanks everyone for joining today. And like I will call it a day today.